Alright, hope everyone's well. I thought I'd cover a interesting concept that I stumbled upon, which is sliding windows. And so it took me a while to grasp, so I'll create a video about it. So the context is, say we have a string, ABC, ADC, and we just want to find the longest substring that doesn't have repeated characters. So if we look at this example, ABC seems like the longest substring, and more specifically, the longest we can the problem which comes from leak code, and I'll show in a second. You have to find the exact longest substring. You just need to find the string length. So, because there could be multiple substrings, that kind of match that criteria. So, in this example, ABC would be an example of the longest one, but ABCA isn't, because A is repeated, and similarly CAD is, but CADC isn't because C is repeated. Now, sliding window, we have two markers. So we have a start and an end marker, or a left or right marker. So let's pretend this blue one is the right marker, so it's the one that moves first, and so it will expand the window, and this one will contract the window, hence the name sliding window. So we just iterate over this substring until we hit a repeated character. So that's when things get interesting. So go 1, so index 0 is A, index 1 is B, no repeated characters, that's fine. Index 2 is C, no repeated characters, that's fine. And then you can pretend that's an iteration of a loop, and every time we will store the max length of the substring in each iteration. So if we were to freeze execution of the program at this point, we will be able to record that the max length is 3, right? Because ABC, that's fine. However, if we resume execution and jump to the next loop, I can use this. This is when it gets interesting. You have A. Now, A is repeated, so we need to do something about this, right? And this is, so we need to contract this start or left marker, because it's no longer a substring without repeating characters. So what we do is we will go to the character that has the repeated substring, and then we move the marker one place up, right? So we'll go through, we'll continue execution to make it clearer. So now this is the same BCA. Like, if we pause execution again, the longest substring at this point is 3 again. Now we'll expand this marker to D, and that's fine, no repeated substrings so far. Actually, going through this execution, I guess the longest substring is actually 4, BCAD. But let's keep going, and finally we reach the end. Let's see. Now, this is obviously a repeated character, so we'll use the same algorithm or rule. We'll jump to see what's repeated, we move it up 1, right? So then we contract the window, right? Now, it's pretty confusing to wrap your mind around that last part of the algorithm, why we do that. Like, why couldn't you, at this point, why couldn't we just move the marker to B? Because this wouldn't be a valid substring still, right? Because if you look at it, C is still repeated. So we have to move it to C, but afterwards, right? We can't move it to C because, well, C is still repeated. So we have to move it to ADC. There's no more characters now. So we can conclude that the longest substring is 4. So that's how kind of sliding window works in a graphical way. We can look at, hopefully that gives you some intuitive idea of how it works. We can jump into code. So this is the problem. So to record kind of all the instances of each character, we use a map. And to record kind of the, I think that's all you need. We'll just write the code and see how it goes. So do split, then a dot. So we're writing JavaScript because that's like the most common language these days. So this just converts, split just converts S. So S is a string. So split just converts it into an array of characters. But in JavaScript, it doesn't really have a concept of characters. It's an array of strings of length 1. So so this is a standard reduce function. So it starts with the accumulator, then it goes to the value or character. Let's call, I think char isn't a special character, so we can, and I'll write this in a verbose way to make it easier to understand. So that's just the reduce function. You kind of just have to remember the parameters it gets passed, and we'll start at 0. So the accumulator is, we could change it to something else like longest that's a bit wordy. We'll just call it longest, and that just tracks the longest substring length, right? So we'll start with the very end, actually, or near the end. Is we want to cache the result each time we pass through it, right? We want to memorize the index of where it is. So we just simply do map char equals index. So that's all good, and so we want to, at the beginning, we want to find if this character is repeated in the map, right? Because that's when things get interesting. So we can say repeated is equal to map char. It's not equals undefined, right? So what this is saying, we can abstract a little bit more or use more variables to try and describe what's going on. Is so we search through the map and see if that character exists already, and this will return us the index of where it is at, because we need to use it later to increment the we need to use it to increment this counter, right? So we check if it is, but if this character, say A isn't in the map, like in the first iteration, it will return undefined, right? So then repeated is false. So what we do here is if repeated, we'll just go with this else condition first. Actually, we just do nothing. If it's not repeated, just do nothing. Right, because let's jump back to this. Let's jump back to the beginning to understand why we do nothing, right? Because the first iteration of the loop, if it's not repeated, if A is not repeated, and B is not repeated, and C is not repeated, we do nothing, right? So we do nothing with so we'll need to create the marker. So we'll just call it select, because it needs to start at 0. So So we do nothing with the left marker, which corresponds to this red marker. But so let's look at the interesting case where it is repeated. So obviously we need to move this marker. We need to move this marker. Right. So how do we do that? So left will equal to simply found index plus 1. Right. Right. So when A was repeated, because it already exists in the map, we just increment the index. We want to go to A, but skip A. So there's still a bug here. And the bug is we also need to check if the found index is greater than or equal to left. So this is interesting. Why we need to have this condition as well, because yeah, so I just edited the example to include the scenario where you can't move this sliding the left marker back. So if we were to go to B, and using the algorithm with the bug, we'd move the marker to B, right, and then go to C. But that's not allowed because there's an issue there. That's not how sliding window works. You can't expand the left marker and increase the substring. It has to be, because in Chile you can see what went wrong because C is repeated twice in that case. So we ignore the fact that B has a repeated character here, back here. It doesn't matter. If B was here, then it would matter, and we would move the sliding window here, the left marker. So hopefully that makes intuitive sense why we added this check here. So the found index has to be greater than or equal to the left marker so that we can actually move the left marker forwards, right? Okay, so just the final turn statement here. So we just do math.max longest so index minus left marker plus 1, because it's inclusive, right? We get the difference, but it's inclusive. So go back to an example once again. Yeah, you get the difference, but it's inclusive of the characters that the markers are pointing to. So if you were to get the difference, it doesn't give you 3, so you need to add 1 to be inclusive. Just a little mathematical trick. So hopefully we run that and it works first time. Just to return. Cool. So that kind of passed all its test cases, and this Leak code's quite nice. It has really extensive test cases, and you can also test it with that. So hopefully that gives you some intuitive understanding of sliding window. It took me a long while to grasp it, but I think we got there in the end with this little example here.